Assalamu alaikum and welcome all to Mathcast with Faria Yusuf. And many of my students have shown concern for this question, which is from February-March 2024, paper 2, variant 2, and it's question number 2 in the paper. And this question is from absolute functions, and we need to sketch the graph and then we have to get the unknown values with respect to inequalities. So I just thought of just making a video to share with you all so that anybody else who have queries about this question, they can just look at this and get it solved and understand. And also you are most welcome to ask any questions or any queries about any paper question or any topic that you find difficult. As for P3, I know students find it very difficult, and they just mismanage in time management and solving paper. So, or maybe they get nervous in solving them. So, you are most welcome to get your queries solved. Just leave a message in the comment box. And please do not forget to like and subscribe the channel and share it also with your friends. It will be a great favor and it will help me in getting motivation to make more videos for you all with respect to your queries. So let's begin with the solution. It's question number 2, and the question says sketch the graph of y equals absolute 3x minus 7 using the coordinates of the points where the graph meets the axes. So using the coordinates of the points where the graph is meeting the axes, so this is one of the hints that I should be considering here. Coordinates of the points where the graph is meeting the axes. So let's start solving this question. So if a function is given so that it's y which equals modulus of 3x minus 7. So it's modulus of 3x minus 7. To get the coordinate axes, what I know is that on the y-axis, it's my x which is equals to 0. So if I substitute this x as 0, I can say it's y which remains with a negative 7 with the absolute sign, or therefore I can say that this function is having the value which is equals to 7. In the same manner, x-axis here, our y needs to be 0. So if our y is a 0, what I see here is that it's absolute 3x minus 7, which should be equal to 0. And then I can say that it's 3x minus 7, which is equals to 0, or x is equals to 7 by 3. So we have the two coordinate axes values here. The second thing that we should know is that whenever we have this absolute function, and for this absolute function, if the question says that this is modulus of 3x minus 7, and the tip here is that if outside the modulus there is a positive sign, I can see this positive sign here, then with respect to the modulus sign, and it is a linear modulus, always remember that the sketch of this graph is going to be a V-shaped graph. Sketch here, it's going to be a V-shaped graph. So at least we know that the shape of the graph should be a V-shaped graph here. So for the x-axis and the y-axis, we already have the y-intercept, which is a 7. So I can mark this 7 here. I can say it's a 7 here. And x is equals to 7 by 3. Let's say x equals 7 by 3. It's the value which is on the x-axis. So just making the graph, I know this being a V-shaped graph, it just needs to follow this pattern here. This is all that we have to do for the 2 marks that we have in the paper. So that's it. No further working, and this is the complete solution for the sketch of the graph for the absolute function 3x minus 7. Let's move to the next part, and the next part of the question, which is again for 2 marks. Now this question says, hence find the set of values of the constant k for which the equation modulus 3x minus 7 equals k times x minus 4 has exactly 2 real roots. So first thing is to have the understanding about the 2 real roots. So whenever we say that there are 2 real roots in the equation, there are 2 real roots, then obviously it means that there are 2 points of intersection, 2 points of intersection, and that means that this modulus function y equals modulus 3x minus 7, and we have this y which is equals to k times x minus 4. If I solve the two equations simultaneously, they will be crossing each other, so that there are 2 points of intersection for these two functions here. Now, this k value, just make sure that you have the understanding of linear equations here. If I look at this equation, which is y equals k times x minus 4, then this is y equals kx minus 4k. So this means that this k here is actually representing the gradient, because we know it's y which is equals to mx plus c. So this m value or the gradient value here is actually equal to a k. So k being a constant and also being the gradient for this function, it has to play a very vital role in understanding the real roots, the set of values for the constant k, which we shall be discussing further. So, because we have to relate the absolute function to kx minus 4k, I should be knowing the gradient function for 3x minus 7. So, the gradient function here is a 3x minus 7. For this equation, what we know here is that this gradient value for this absolute function is actually a 3, but then because of the modulus sign, it can be a plus 3 and it can also be a negative 3. So with the plus 3, we know that the function or the gradient has to be the gradient which shall be increasing or sloping up, and with y which is equals to a negative 3, it shall be having the gradient which is a negative 3. Meaning in this case, I can say that the gradient value here, it's a negative 3, and in this case, the gradient value here is a positive 3. So after doing that, what I know here is that if I have the line which is y equals kx minus 4k. So kx minus 4k, if my k has the gradient which is negative 3, I'll just start assuming that if my gradient here is a negative 3, then obviously this line which is y is equals to kx minus 4k, it is going to be parallel to this part of the line with the gradient as minus 3. It is going to be parallel to this part of the line, meaning if your gradient is a negative 3, then the lines that I should be having here shall be equal to, now again, it's a negative 3. If I just substitute these values with negative 3, what I will come to know here is that this is a negative 3 and this is negative 4 times negative 3 and this negative 3x. So this becomes a negative 3x and a positive 12. So this means it should be having the y-intercept which is a 12 with the gradient as negative 3, and the x-intercept then shall be equal to a 4. So this line here, if I just sketch the line, then I would know that this line here shall be passing the function, the absolute function, the y-intercept here, which shall be equal to 12, the y-intercept here, it shall be equal to 12. The x-coordinate here, this shall be equal to 4. And I can see that it is not going to intersect the absolute function at 2 points. It's just intersecting the absolute function at just 1 point, meaning there is just one real root with respect to the gradient value, which is equals to negative 3. So what I can see here is that if I have the gradient values which are maybe less than negative 3, let's try with the gradient values which are less than negative 3, gradient values to be less than negative 3, meaning in this case it's k which is less than negative 3. So let's go for the k value which is equals to negative 2. So with this k value which equals a negative 2, if I do some working here, then again having the equation which is equal to kx minus 4k. So what I know here is that with this k as a negative 2, it's negative 2 times x and then minus 4 times negative 2. This would give me the equation which is a negative 2x and a positive 8. So this gradient value negative 2 and I can see that my y-intercept here is an 8 and my x-intercept here with my y as 0, my x-intercept shall be equal to a 4. This x-intercept shall be equal to a 4. So y-intercept being 8 and x as a 2, again, what I will find here is that this graph shall be, for this equation with k as a -2, what I observe here is that my y-intercept here is an 8 and my x-intercept is a 4. Meaning if I just sketch this line with x-intercept as 8, with y-intercept as 8 and x-intercept as 4, I am actually getting two intersection points with the modulus function. The two intersection points, let's have these points here. I can see that one of the point is here and the second one is here. And this is what we want, two real roots. So with two real roots, I have tried the value with k equals a -2 and I'm getting this, these two intersection points. Let's move on with some more values of k. I've tried with -3, which was giving me just one real root. I've tried with -2, which is actually giving me two real roots. So now if I go for the k value, let's say that the k value here is a -1. So again, my equation is y is equals to kx minus 4k. And if I substitute this k with the -1, then the gradient being negative, so the gradient here being negative, and this becomes a 4. So this means that my y-intercept here, y-intercept is a 4, and my x-intercept with my y as a 0, this also comes out to be a 4. So I shall be again making the graph with respect to the two intercepts on the x and the y axes, and let's see what we shall be getting here. So with this line that I have drawn showing the x-intercept, which is a 4, and sorry, the x-intercept which is a 4 and the y-intercept which is also a 4, again what we see here is that there are two intersecting points here, which actually we want for the k value. So again we are getting two intersecting points, so therefore it's giving us two real roots. Now after -1, if I just substitute k as a 0, then with k as a 0, what I will get here is, for if I say that my k value is a 0, I will be getting y which is equals to a 0, which is actually representing the x-axis. And again at this point, what we have seen here is that with k as 0, it's y is equals to 0, which is representing the x-axis, and the x-axis and the line, they are just giving us one real root. So with this discussion, what we have come to know is that if my k values, they are within the limits of 0 and -3, or -3 and or -3 and 0, what I know here is that the line y is equals to k times x minus 4 and the absolute function 3x minus 7 will be having two real roots as shown in the diagram. Therefore, the set of values of the constant k, which is representing actually the gradient value here, the set of value then becomes should be -3, which is less than k, that should be less than a 0. So this is how I shall be getting the values of k for this function here. So I hope this video is useful to all, and it's useful to everyone, and you have learned to get the values of k. Some queries about the question is that usually these functions are solved by uh, squaring both the sides. So even if you square both the sides, you have to keep in mind that this k value is actually representing the gradient function. So with respect to the gradient function, you have to go by this trial and error method, comparing the gradients of the absolute function so that you can get the actual value of k here. So I hope you enjoyed the video and you have learned a lot from this video and the solution is clear to all. So wish you all the best, and do not forget to like, subscribe and share. We actually work a lot. The work is really hard to make these videos for you all. So please make sure that you have given a little appreciation by just subscribing and liking or giving a comment to this video. So thank you and Allah Hafiz.